Hello and welcome to Lesson 23.3 in the Python tutorial series. Lesson 23.2 is going to continue the topic that we started in Lesson 23.1, that of the list data type. Now the list data type really is unique in the way Python handles it. Lesson 23.2 that we're doing here is going to specifically deal with list mutability. Now, if you've never heard the word mutability before, what we're talking about is the ability of this data type or these variables to change. The way Python changes a list variable is quite different from the way it changes integers or strings. It's also something that's important to note because it can have a big impact on your programs and the way that they run. So we'll be providing some examples in Lesson 23.2 that show just how the list data type is handled differently than the other data types in terms of mutability. So let's go ahead and head over to our Python programming window and get started with Lesson 23.3 on list mutability. So here we are, we have a fresh Python window open. We have our Python shell and an untitled program here. And we're going to be doing most of our work inside the programming window because one of the things that I want to do to help provide an example of mutability is put this into the Python visualizer. We haven't used that in quite a few lessons, but it might help to help everybody understand how Python is handling this issue of mutability. So let's start by just creating a string. And I'm going to create a string named house, or with the value house stored in it. And let's go ahead and establish this right here. So I'm going to name this Python file here, lesson 23.2, lesson 23.2.py. And so when I run this program right here, I get a variable, myString, which I can access in the Python shell, equal to house. Now what I might decide I want to do is change this string to mouse instead of house. Well, I know from index location that I can access string at index location 0, and that contains the h right here in house. What I'm going to try and do is use my string at index location 0 and change that specific character to an m to change the word house to mouse. See, I get a type error. String object does not support item assignment. I am not able to change my string without changing the entire string. That is, I can't use index notation to affect just one character, and I can't use slicing notation to impact a small bit of characters. My string is my string, so a string is said to be immutable. Once the string is established, I can't change parts of the string without completely establishing a new variable. If I wanted to change my string to mouse, I'd simply have to go in and recode it, or down here in my Python shell, assign the entire string to mouse. So that has to do with the mutability of strings. Let's take a look at how lists are a little bit different. Over in my programming window, I'm going to initialize a list variable, and I'm going to call this states. And we'll start with Arizona, California, Florida, and let's finish with New York. So it's a list variable that contains 4 different states. If I execute this program now, I have access to my string and states. States contains Arizona, California, Florida, and New York, and as you saw in the last video, I can access those individual elements using index notation. Lists are different in that lists are mutable. If I decide that I don't want New York in my list, I want to change New York, I am able to go to states at index location 3, which is equal to New York, and set that to a new variable. So if I said states at index location 3 is no longer New York, I want this to be equal to Colorado. I don't get an error with my list type variable. And indeed, if I look at states, I can see that New York has changed to Colorado. Because this is a list and lists are mutable, I can use index location to change the elements of my list without getting an error like I do with a string variable. Now let's go back to my string for a bit. I'm going to program a small function here in my programming window. And this function is going to be called change string, and it's going to take my string as an argument. And this function will change my string, or something to that effect. And what I want this to do is take my string and set it equal to mouse instead of house, and then return my string. If I execute this program and run change string and pass in my string as an argument, so let's pass in my string, I can see the return value is mouse. That's because my string here is mouse, but if I check the value of the global variable my string, it's still equal to house. If you remember back to how local and global variables are handled, this my string as an argument has the variable house passed into it. So the running of this function, my string equals house. I then take my string and set it equal to mouse, but this is a local variable. Once I exit this function, it's not going to be equal to mouse anymore. In fact, this version of my string is going to go away. I return my string, which as a local variable is equal to mouse, and I can see that reflected here in my Python shell. But after this entire function is done running, my string is still equal to house because this my string is a global variable and I can't adjust the value of a global variable within my function. To kind of help you visualize that, if you don't remember it from local and global variables, let's go ahead and just call this function real quick, my string. And instead of running this program, we're going to copy and paste it and put it into the Python visualizer. If you don't remember the Python visualizer, you can look at one of the earlier videos in this series, and it will show you where the website address is and how to use it. But let's go ahead and execute this program now. We see that my string is now a variable in the global frame set equal to house. States is a list variable in the global frame that has index location 0 Arizona, 1 California, 2 Florida, and 3 New York. And now we've defined a function called change string. The next thing that's going to execute is this change string function call, passing in my string as an argument. And so when this is called right here, I can see my string gets an argument house passed into it. The first thing that it does is set my string equal to mouse. And you can see now my string has a value of mouse, but it's in the change string stack. It's not in the global stack. So when this is executed, it returns a value of mouse that's displayed on the screen as you saw earlier, but it did not affect the value of house as a global variable because this mouse was a local variable in the change string stack and not the global stack. Hopefully that was just a little bit of review for you. Let's go ahead and try something else though. Running this program one more time, I'm going to access the states variable and see that Arizona, California, Florida, New York are there. I'm going to write a new function called change list, and that's going to pass in a value of states. This function will change states. And I'm going to do a couple changes in here. The first thing I'm going to do is take states at index location 3 and set it equal to Colorado. So that would replace New York. And let's take states at index location 1 and set that equal to Washington. I'm not going to have a return statement here. Now I can have a return statement if I want, but to provide this example right here, I'm not going to have a return statement on the end of change list. If I execute this program, you'll see that states has its initial value of Arizona, California, Florida, and New York, just like this right here. When I run change list with states as an argument, and then check states again, I can see that this list did change. Washington is now at index location 1 and Colorado is at index location 3. But I did this in a function. It's not that list variables are passed in as global variables. Because list variables are mutable, any changes you make to your list variable, whether you're in a function or whether you're in your main program loop, will be permanent. Local variables don't work the same way with lists. So be aware that if you wanted to change the value of your lists while running your programs, they don't necessarily need to be a global variable. Now, in fact, one thing to keep in mind when you're doing this, I can even take states out of the argument here and just run change list, having not passed in the value of states at all. If I execute this program again, I can see states is in the global stack because I have access to it there. And if I run change list, passing in no argument, I'm not getting an error, and the value of states is still changing with the change list function. So in a manner of speaking, you can think of list variables as being global all the time. Because they're mutable, all changes you make to list variables are permanent. That's a very important feature of the list. And I can show you what happens here if we run change list here at the end of this program and go ahead and copy that into the Python visualizer. So let's hit back and change this. And we'll go ahead and visualize the execution. See, my string gets established in the global frame, states gets established. And the big thing that makes a list different, you'll notice that my string here is in the global frame. States are considered objects, and objects are more global, I guess is the best way to put it. So when we run change list now, it runs up to change list, and because it's accessing an object, it doesn't matter that this isn't in the local frame. When states 3 equals Colorado, I can see before that executes, index location 3 equals New York. The change is immediate. It doesn't wait for the function to end its full function call. Once the states at index location 3 equals Colorado is run into, that change is made immediately. See, California is still at index location 1, but of course on the next line, it's going to change to Washington. Every function returns a value, and since this doesn't have a return statement, this function is going to return a value of none, but it doesn't matter because we didn't save this to a variable. And you can see that our change is pretty much permanent. So that right there was just a quick lesson on list mutability. This was more of an add-on lesson of things that I thought were important to discuss before moving on to the next lesson. The next lesson is super important. The next lesson will show you how to add items to the end of your list, to randomize the order of your list, to pull items out of your list, and some things that make games and other applications pretty advanced or pretty powerful. So that'll be lesson 23.4. It will be more about how to change and manipulate your lists, but knowing this mutability feature of lists, or knowing how Python handles lists in this manner, is something that's really important to remember going forward because it's completely different than the other data types that we've looked at. As always, if you have any questions about anything that you saw here or something wasn't clear, go ahead and leave that in the comments and I will be happy to help you figure it out. Thank you so much for watching. I look forward to seeing everyone back for lesson 23.4, and have a great day.